All right, section 2.2, we're going to talk about sets. Sets are discussed in lots of different math classes. On campus here specifically, we talk about sets in both of our algebra classes, Algebra Intermediate and College Algebra. We talk about sets in some upper level math classes. We talk about sets in contemporary math. We talk about sets in discrete math. They sort of show up at lots of places. And then you talk about them, but you probably don't think about how you talk about them at lower levels of math as well. So we're going to take a look first at what do we mean by a set. A set is just any collection of objects. Any collection of objects. The elements are those individual objects that are in the set. So this could be, the contacts in your phone. That's a set of objects. It is. And the elements would be each individual person's contact. Okay? This could be the, pots and pans in your cupboards. Right? The pots and pans would be the individual objects. This could be the members of your family. The set is your family, and then each individual person is one of the elements of that set. So it literally can apply to anything you'd like, as long as you have a collection of things or people or something, places. And then there's a couple of ways that we're going to talk about describing these sets. One of them is called the listing or the roster method. And with this method, what you do is you simply, in both methods, you use these curly brace things, okay? If you can't draw them real well, it's going to be okay. Just do your best. And you literally list the items out. So if it's the members of your family, you write their names down, right? If it were the contacts in your phone, heaven forbid, there's like 500 of them or something probably, and you'd write all of them down. This is the listing method. So in some cases, this is a small list. In some cases, this is a big list. It just depends on what we're talking about. If you're working with numbers and they continue on and you want to put ... dots, you can do that too with the listing method. This idea that it continues, but you can't stop the process. The listing method tends to work better for smaller groupings, right? You're probably pretty okay when I said you could list the members of your family, and you were probably less okay when you thought about listing all the contacts in your phone. Agreed? Yeah. So it tends to work better, the listing method, for smaller groups of things. The caveat to that is like the one I did where you can put the ... in the end. Obviously, that's a list that continues on forever, and you sort of have a workaround for that one. But most contextual things, you can't just put ... and it makes sense, right? Numbers are a little bit unique. But there is another notation called set builder notation that allows us to write things that are infinite, especially infinite, or that simply have a lot of things in them in a more compact way. So it's a shorter process to write them. So I'm going to write this same set right here that we have, where it's smaller, okay? So I'm going to write it out, and then I'm going to tell you what all the symbols mean. So just bear with me for a moment and just copy down what you have. You've got a curly brace, you've got an X, and you have a vertical bar. And then you have the inequality x is greater than or equal to 7. And then we have x, we have this funny little symbol that looks like a C with a line through the middle of it, or kind of a curved E. And then we have an N with a line on the left, double line on the left. So just jot it down and then we'll explain all the symbols. Okay, so my next slide and your next set actually talk about some of those symbols. So I'm going to switch slides, but I'll come back to this one and talk a little bit further about that example in a moment. The first symbol that I'm going to talk about is the symbol that looked like that sort of curved E. And it really does need to look like that. You can't go doing this for me. Like, that's not going to be okay. You don't get to choose how to write the letter. So it really does look like that. This is the symbol. It just happens to look like an E. It's actually kind of nice that it looks like an E because it actually means is an element, as in the letter E, element, right? Element of. So we're just saying it belongs to it, right? So I am an element of the set, the Hands family, right? You all are elements of the set OBU students. You are all elements of the set female. You are all elements of the set, you fill in the blank. Whatever the categorize, however you can categorize yourself, you're an element of that grouping. Okay? What do you think happens when you put a line through it? Yeah, it just means you're going to put the word not in there. So it is not an element of. Right? So for me, I would say I am not an element of the set single ladies, right? Like I'm not single. So that would be an example. So anything that you are not an element of, if you use that symbol, that's what that would be used for. Another symbol that you saw used on the last example was the N with the line on the left. This is natural numbers. Natural, or they're sometimes called counting numbers, are the numbers children very first use to count with. And where do you start when you very first learn to count? 1, right? You go 1, and then you go 1.5, and then you go 2, and then 2.5. Probably not. You go 1, and then you go 2, and then you go 3, right? So those are our natural numbers. And so I'll write them out in a list as well to kind of remind us here. Our counting numbers, or our natural numbers, look like these. They're very first numbers children learn. The next number they almost always learn, any guesses as what it would be that they need to add into this list for it to make sense or give them a broader idea? It's usually number 0, right? This list that I've written out right now does not include 0. And they come to need the number 0 very quickly because they subtract, yeah? You got to do 3 minus 3, you need a number for that. So if we expand our view of numbers by one number, you get the whole numbers. So whole numbers are just like natural numbers, but they also include the number 0. Or you could say they have a starting value of 0. So 0, 1, 2, 3, and so on. Those are whole numbers. If you're looking at the amount of space you have, I have 3 more to tell you about. You might have to squeeze them in somewhere else. The next one I have, it looks like a Z with a double line in the middle. These are integers. If you've taken contemporary math and you've learned this material, that book avoids using this letter, Z, for integers, which is the commonly accepted letter to use across mathematics. I don't know why it does it, just sort of an awareness factor. It has to do with, I can't remember which language it is. I think it's Greek. But whatever language is that the word integer is in, uses the letter Z at the beginning, like when that was defined originally. So that's where it's coming from. Do you remember what integers are? Yeah. So it's the same list we already have, but then we're going to include the negatives of those same values. So in an effort to try to be sort of, listing all of them out, we'll put a dot, dot, dot at the beginning now, and then we'll do -3, -2, -1, 0, and then 1, 2, 3, and so on. So we get the positives and the negatives. Interestingly enough, sometimes those don't come as quickly for students in curriculum as the next one. It sort of feels like they should because we're sort of building on what we have, but they don't always come next. Sometimes rational numbers come next instead, like fractions. Okay, so the rational numbers is not a letter R, it's actually the letter Q. The reason it's a Q is because Q stands for quotient, and quotient means division. So you think about a fraction, right? So think about your fractions like P over Q. something else, I'm dividing. That's what that bar between them means. It means division. So we look at this and we say this is a ratio, so we get rational numbers. Or we can say this is a quotient, and that's where we're getting the Q. So that's the connection between the letter and the symbol here. So this is P over Q. These are rational numbers. And there isn't any good way to write these out, all right? So the best you can do is to write down that they are the fractions P over Q, like this, where P and Q are elements of the integers. So if you have integers, 3 and 7 and 59 and negative 427 and things like that, and you put them one over the other, you create rational numbers. Kids start to hit fractions pretty hard in 3rd grade, just to let you know. Not to scare you, I'm just letting you know. Right, Jewel? Fractions? Yeah. Okay, the last one is R. These are real numbers. So real numbers include all rational, so all of the rational numbers, Q, and irrational. And you might not necessarily know exactly what I mean by irrational because it feels like I've written out a lot of types of numbers so far. You know, kind of like, well, what is missing? Irrational numbers are numbers like square root of 2, right? Or pi. Pi is irrational. Another one you see usually in an Algebra 2 course is the number e. It's about 2.718. Those are just examples. There's infinitely many rational numbers. You can probably imagine that because the radicals themselves take care of lots of things, right? You can do square roots of anything that's not a perfect square, and it will be thrown in here. So we have square root of 2 and square root of 3 and square root of 5 and square root of 7 and lots of them, right? So we get lots of numbers from in there. All right, so let me come back over here and talk to you about how we read set builder notation. Set builder notation says, this is all x. This bar is the phrase such that. All x such that. X is greater than or equal to 7, which looks like it from up here, right? And x is a natural number. And we need to say that it's a natural number. We need to make sure that we're not including the square roots and the decimals and the fractions that are bigger than 7. So we have to say what type of a number we're talking about for us to be clear. Is that all right? Okay, let's do an example. We're going to do an example for the set of all numbers less than 5. Using all natural numbers. There we go. I have a typo on my paper, but it's right in the slides. The set of all natural numbers less than 5 using the listing or roster method, and then doing the set builder notation method. Okay, so both methods start out with a curly brace. The first one lists them out. What is the list of all natural numbers less than 5? Where would we start? Is 0 natural? No. 1. Yeah, so remember 0's whole. And the question could have just as easily said all whole numbers, right? Like that could be an answer, a question too. So just pay attention to the structure of the question. This one's a natural number, so natural numbers. So we start with 1, and how far will we go? Well, what's my next one? 2. How far will we go? To 4. Yeah, so why will we stop shy of getting all the way to 5? Yeah, it specifically said less than. Okay, so the fact that it's natural and the fact that we have the less than sort of hem us in on what we can write down as pieces that satisfy this. Set builder notation always starts out the same way, and you don't have to use an X. So if you like another letter better, then feel free to use it. I tend to just go with X and a bar. This is X such that. And then I have two conditions that I have to describe because there are two conditions in the description I was given. One description talking about the less than, and one description talking about the natural numbers. And I don't really have to have them in any specific order. So if you just want to do the order that it's given in the question, that's fine. The first thing it says is X is a natural number. Well, I do that by writing down an X. I do that element of business, and then I write the natural number. If you want to write that at the end, you can write that at the end. It doesn't matter. The other condition said that X is less than 5. That's algebra notation that we've seen since a pretty young age where they started working with the less than symbol. And X is less than 5, like that. And again, you can swap the order of these if you wish. It doesn't change the product or change the process any. Okay, we're going to pause there because the next set of vocabulary goes with the next example. We'll keep those contained together, and we will pick up where we left off on this on Monday.